Good morning or good afternoon or good evening or whenever you're watching this video. I hope you had a great spring break. I would say I did, but I haven't had my spring break yet. But we're going to teach you the Pythagorean theorem. All right, now most of you I think know the Pythagorean theorem, but most of you might not know how it's developed. Didn't it just come out of anywhere? It was developed, and we can see this, how we developed this and how we come about with the Pythagorean theorem. If I take four triangles of the same size and piece them together so that I have a square in the middle, okay, we can come up with a formula for the area of the whole square. Now we know the area of a square is the length of a side squared. So what is the length of one side? Now you may think, well, it's AB. But you got to realize is that what we're doing is adding two lengths. So actually one side of the square would be A plus B. All right, so the area of the entire square is A plus B squared. All right, the area inside, we see the one length, we made the hypotenuse C. The area of the square inside would be C squared, or C times C. All right, and the area of one of the triangles, now we see it has a base of A and a height of B, so the area of the triangle would be 1/2 A times B. All right, now if we were to add up all of the triangles together to get the total area of them, we would have 1/2 AB plus 1/2 AB, which would be 1 AB, and then we add up the other two, we'd have 1 AB plus 1 AB, so the area of all four triangles combined would be 2 AB. All right, I'm going to show you over on the board, Chloe, if you could follow me here. Over on the board, how we come up and how we develop the formula for the Pythagorean theorem. All right, now we said that A plus B squared is equivalent to the whole thing. And we also said that if we took all four triangles combined, their area was 2AB. Now you got to be able to read the board, Chloe. Can I read the board? You might want to zoom in and get a clearer picture of the board.
I think they can.
I'm not as important, Chloe. You need to get the board. All right, maybe not that close. Okay. All right, is it good? Can they see it good? All right. So you've got 2AB. All right, is the area of the four triangles, and then we need to add the area of the square to it, which is C squared. Okay, and so we have two expressions that would be equivalent to the same thing. All right, now if we simplify this, so we square this. Okay, if you square them, remember, easy way to do this, you have A squared plus B squared, and then in the middle we do A times B and double it. So it'd be 2AB. All right, now we look over here, and we've got 2AB plus C squared. Now if you look at this, starting to look like the Pythagorean theorem. They've got 2AB on both sides, so if I subtract 2AB from both sides, you get A squared plus B squared equals C squared. Okay, and they came up with this formula for the Pythagorean theorem. Now, interesting thing about the Pythagorean theorem is that it was around when Jesus was alive. So the question my wife and I asked is, we know Jesus probably used it in his carpentry, but did Jesus really have to learn it, or did he already know it? And we'll leave that up to you for debate. All right, let's get back to this. Now let's work some of these Pythagorean theorem problems out. All right, now the big thing to remember is that the C squared is always the hypotenuse or always the largest side of the triangle. All right, so our two legs, 6 and 8, they're the two sides that attach the right angle. Those two are always going to be on one side of the equation, and the hypotenuse is going to be on the other side. All right, and we already worked this out, so we'll go through it. So you should ask yourself right now, before I do it, you should ask, I'll ask you, okay, how would I set this up? And hopefully you would set it up right. Pause for you to write that down on your paper. Hopefully you would write 6 squared. Oh, I'm sorry, there's the formula. 6 squared plus 8 squared equals C squared. Remember, the hypotenuse is always going to be the one by itself. Now you may also be asking yourself, well, what if I put the 8 first? Does that matter? Well, it's addition, and we know the properties of addition. You can move they can switch spots, and that's okay. All right, so we work this out. We square each before we add them. So we have 36 plus 64 equals c squared. When we add those together, we get 100 is equal to c squared. Now, remember with equations, it's all about undoing things. So what undoes a square? It's a square root. So we take the square root of 100, and we would get 10. All right, so there's our first Pythagorean theorem problem done. All right, next question. Now, they've turned the triangle sideways so that we make sure that we set this up. Right now, what are the two legs? Give you a second to think about that. All right, hopefully you said to yourself, T and 4 are the two legs. They're the two sides that make up the right angle. Okay, the two sides, 4 and T. So there are legs, they're going to go on one side, and 7, the hypotenuse, the other side, is going to go on the other side of the equation. Find out where I did it here. All right, so you should have it set up this way. 4 squared plus T squared equals 7 squared. All right, now we're going to work this out. All right, what is 4 squared? 4 squared is 16. What is 7 squared? 7 squared is 49. All right, now working out the equation, we want to get T by itself. So we've got to undo. We see addition here. All right, the square and the square root, we're going to do that last. But addition, what do we do to undo addition? The inverse of addition is subtraction. So we're going to subtract 16. Remember, what we do to one side, we also have to do to the other side. All right, now we'll have T by itself. T squared equals 33. And then the final step, okay, final step would be to take the square root. Now, square root of 33 doesn't simplify, so you can just leave it just like that. All right, another setup. All right, what is the hypotenuse? Which one is going to be the one by itself? Yes, you answered correctly. Square root of 61. Good job. All right, so square root of 61 is going to be by itself. My daughter's laughing. I think she had no clue. She thought I was asking her. All right, but square root of 61 is by itself. We'll set this up. So we'd have k squared plus 5 squared equals the square root of 61 squared, just like this. All right, now we're working it out. We want to square. Now, square root of 61 times square root of 61, what is that? Well, we shouldn't have to do any math. Remember, any square root times itself, like the square root of 3 times the square root of 3 is the square root of 9, which is 3, or the square root of 7 times the square root of 7 is the square root of 49, which is 7. Now, anytime we multiply two like square roots, it's just the number underneath. So the square root of 61 squared, it undoes that, and it just would be 61. All right, and we have k squared. Oh, and I'm working this out, and I don't know why, because we've got it over here already. All right, let's go erase that. All right. Okay. All right, so we work this out. Oh my goodness. They're not working now. What is wrong with it, Chloe? Because all right. Oh, it's highlighting the text box instead of clicking on it. All right, I guess I will work on this until we figure out what's wrong. Maybe it's because I have, maybe just, I don't know, because I wrote on it. I'm not sure. Okay, it's not working like I want it to, but that's all right. We'll go ahead and work it out. Oh, maybe I need to try one more thing. No, it's not working. Okay. See if that's true with all of them. Yeah, they're all going to do that. All right, so I'm not sure why that's not working out, but we'll go ahead and work it out ourselves. So we would do this like we were doing k squared plus 25, and maybe because I started writing on it, equals 61. We do the same thing, inverse operation. Subtract 25 from both sides. 36 is equal to k squared, so take the square root of that, k is equal to 6. All right, very good. All right, Pythagorean triples. Let's go ahead and read the definition. You can read it as I read it. Chloe, if you try to get it zoomed in there, so make sure that they can read this. Pythagorean triple is a group of 3 non-zero whole numbers make sure we pay attention to that whole numbers. And C, that represents the length of the sides of a right triangle. Two triangles whose sides lengths are Pythagorean triples are shown below. Okay, these are common. If you can memorize them, we can actually save ourselves time from doing the Pythagorean theorem. 3, 4, 5 triangle, and we have a 5, 12, 13. Both of these work, and if it works, we know it's a right triangle. Now, emphasize again, we only call Pythagorean triples those that have whole numbers. So if it doesn't have a whole number, we're going to eliminate that right away. All right, so we look at this. 9 squared, and I left 9 squared off, but you know it should be there, plus 40 squared is equal to 41 squared. So we're going to work this out. Okay, when we do, we get 81 plus 1600 is equal to 1681. 1600 plus 81 is 1681. So this works, and if it works, if this Pythagorean triple works, then we know, yes, it is, okay, it is a Pythagorean triple. All right, so this one would be, the answer to that would be yes, meaning it has to be a right triangle. All right, now we're going to look at this one. 8, 10, and 12. Is this a Pythagorean triple? Now, one thing I forgot to mention is 12, the largest side is always the hypotenuse. Okay, so that's always going to be the one that has to be by itself, and the other two are going to be the legs, so we'll put them on the other side of the equation. So we set this up. 8 squared plus 10 squared is equal to 12 squared. All right, work that out. 64 plus 100 equals 144. Is that true? That is not true. All right, Chloe got that one. Okay, so as a Pythagorean triple, the answer would be no. All right, let's look at letter C. 7, 11 and the square root of 170. Now, I started by mistake working this out, but I should recognize that this is not a Pythagorean triple right away, because square root of 170, is that a whole number? No, it is not. It is not a whole number, so automatically we would say it's not a Pythagorean triple based on its definition. Now, it might work, but by definition, we're only looking for numbers that are whole numbers. Oh, let's take that away. All right, pretend you did not see this. All right, a ladder in the diagram satisfies the 1 in 4 rule, a rule of thumb for the safe use of ladders. The rule states that when the bottom of the ladder is positioned X feet from the base of a building, the top of the ladder should reach a point 4x feet off the ground, or 4 times as long. We see that 5 and 20 feet. This is interesting. I wish I knew that. I've probably been unsafe going up ladders sometimes, but maybe I would measure that out and make sure it's true. All right, find the length of the ladder in the diagram. Round your answer to the nearest tenth of a foot. All right, so we set this up, 20 and 5. Okay, there are our legs. C is our hypotenuse. We see this diagram, so we're going to figure out the measure of that ladder. So 5 squared plus 20 squared is equal to C squared. All right, we've got 425 is equal to C squared. All right, once we add these up, 25 plus 400, then we take the square root of C squared. All right, when we do that, we get the square root of 425. All right, from there, we can put that into our calculator to get a decimal answer. Or you can either have a decimal answer, or I may ask you to keep it as a square root and simplify it. Okay, if I do that, look here, square root of 425. Well, I know that 25 goes into 425. Let's see, it'd be 9 times. So we get the square root. It'd be the square root of 25 times the square root of 9. All right, square root of 25. Oh, I'm wrong. I thought there was something wrong with that. Okay, square root of 25, there actually would be 17. All right, 17, I miscalculated. Okay, square root of 25 is 5, and then radical 17 doesn't simplify. Okay, 17 is a prime number, so you just get 5 radical 17. Like I said, you either get a radical number or a decimal. If they they ask us to round to the nearest tenth of a foot, so we'll plug that into our calculator and see what that is. All right, thank you for watching this video. If you got a comment or a question, just write it underneath. We'll try to have a time where we can do Facebook Live or something like that, where you can ask your questions and I can help you go over those. All right, we'll see you later. Bye.